Hi, my name is Anshu Kumar and I am a data science intern at Eagletfly Solutions. Today we are going to discuss about Apache Spark. So let's start. Apache Spark is an open source distributed processing system used for big data workloads. It utilizes in-memory caching and optimized query execution for fast analytic queries against any data size. It provides development APIs in Java, Scala, Python and R, and it also supports code reused across multiple workloads such as batch processing, interactive queries, and real-time analytics. Now let's discuss some differences between Hadoop and Apache Spark. In Hadoop, processing data using MapReduce is slow, whereas in Spark, it is 100 times faster as it is done in memory. Hadoop performs only batch processing of data, whereas Apache Spark performs both batch processing and real-time processing of data. Hadoop has more line of code as it is written only in Java, whereas Apache Spark has fewer lines of code as it can be implemented in Java, Python or R. Now let's discuss the component of Apache Spark. Spark Core, which works as the foundation of the platform. Spark SQL, which is used for interactive queries. Spark Streaming, which is used for real-time analytics. Spark MLlib, which is used for machine learning, and Spark GraphX, which is used for graph processing. Now let's discuss each of them one by one. Spark Core. It is the base engine for large-scale, parallel and distributed data processing. It helps in memory management, scheduling and monitoring jobs, fault recovery, and interacting with storage system. Now let's discuss one of the important term of Spark Core, which is Spark RDD, that is Resilient Distributed Dataset. It is the fundamental data structure of Apache Spark and it is an immutable collection of objects which computes on the different node of the cluster. Now let's discuss some of the features of RDD. Resilience, partitioning, lazy evaluation, immutable in nature, and in-memory computation. Next is Spark SQL. Spark SQL is a distributed query engine that provides low latency interactive queries up to 100 times faster than MapReduce. Now let's discuss some of the features of Spark SQL. Integration with Spark, unified data access for batch processing of hype tables, immutable, and performance and scalability. We can see that when we increase the number of iteration, Hadoop takes more time to iterate, whereas Spark SQL takes very less time. So we can clearly see that Spark SQL is far better than Hadoop. Next is Spark Streaming. Spark Streaming is a real-time solution that leverages Spark Core's fast scheduling capability to do streaming analytics. Now let's see some of the major aspects of Spark Streaming. Fast recovery from failures and stragglers, better load balancing, combining of streaming data with static dataset and interactive queries, and native integration with advanced process libraries like SQL and machine learning. And the last is Spark GraphX. It is a distributed graph processing framework built on top of Spark. It also provides exploratory analysis and iterative graph computation to enable users to interactively build and transform a graph data structure at scale. Now let's see some of the features of GraphX. It offers flexibility and works seamlessly with both graphs and collections. It comes up with various graph algorithms and a high flexible API, and it is one of the fastest specialized graph processing engine while retaining Spark's flexibility, fault tolerance, and ease of use features. Now let's see which company uses Spark. So we can see that there are different companies like Big4Night, Yelp, Zillow, CrowdStrike, which uses Spark. This was the basic introduction of Apache Spark. Hope you like it. This was from my side. Thank you.